So, okay, thank you. Thank you, Jen, and thank you everyone for attending the talk. My name is Xin Yue. I'm from Landscape Architecture and Urban Planning. I will talk about how our team working on the digital twin idea, mainly for urban disaster science. First is if we, some of you might know the National Science Foundation have urban sustainability program. Under that, they list 5 major challenges for planning communities in the 21st century. So I just highlighted some keywords in red. So from what the NSF's perspective, certainly they are interested to see how we predict the future. I mean that here the future is not the long-term future, it's also the near future. And they very much will look into the what kind of theories support this kind of understanding, because theories means you need to put together technological and social science theory together. And as many of you have just demoed, digital twins not only have physical elements, it includes built, natural, and social system. The major reason is only human being is center of digital twin. At least in my perspective, from planning perspective, how you can serve the human better. So for that, certainly we look into how different layers, social, built, and natural layers interact with each other. And how we can transport a successful innovation in one community to another one. It will also be a good interesting thing, because for digital twin, you're not talking about is only monitor or turn the current physical environment to another twin in the digital environment to have the interaction. It also means if certain parts of digital twin functions very well in Galveston, Texas, can it be transferred to another island in Florida? So certainly, no matter how we do digital twin, we need to give it to the hands of the community, how to enhance policy making and the local community residents involvement. It will be the key for the success and the sustainability of digital twin. Recently, I published a paper talking about how to define the computational social science, computational urban science. So I argue that computational urban science need to be human dynamics centered, platform based, action oriented, convergence driven. So for that is I would say the digital twin, it will serve as a kind of a technological framework to realize as a computational urban science. I'll give you more examples in the following slides. So I understand the digital twin very much from the David Planter's very famous book called The Mirror World, because in his book, it's last century, the book is he mentioned if in the future we open the computer tools is not just compiles computational evidence. Instead, it opens the real world in front of us. So later, digital twin the first enters the manufacturing, but nowadays, as many previous presentation demoed, we are looking to the built environment sustainability. And luckily, as a PI, I received an SF grant to build a digital twin for the Galveston Island in Texas. Actually, the purpose is we want 3 different planning scenarios to test for the urban development and sea level increase and different decision makings. How all these things involved together for the whole city's sustainability. And we built a kind of this is some framework we are going to kind of implement. And if you look at that, certainly you see some technical things, how to data fusion, how to link diverse data together. I think that's already been discussed in many digital twin literatures. But I really want to say something about how you can better engage citizens. Why you make them to feel it's important. Why, I mean, from a human being's perspective and from a common citizen's perspective, why I need to view the built environment in 3 dimensions. How I can get exposed to different messages. How can I communicate with other experts, though we are at different knowledge levels. I think there's many things we need to do to really make the deep twin from the more technical toy to our daily, I mean, like the friend who can assist us in decision making in our daily life. So we are working with a group of architects and landscape architects. We are proposing some AI-driven, it's also like a digital twin for resilience planning and design. And for that is we are building and integrate knowledge from micro to all the way to the macro, because when we talk about flooding for disaster planning, it's not only how your building it has a design standard. You also need to take care of your kind of the nearby infrastructure design, like green infrastructure. At the more macro level, we also pay attention to see how your long term, are you in the flood plain, or whether there's any kind of the hydro engineering projects will impact your property value. So all of them linked together allows common citizens and the planner, decision makers to co-design. So for that is we certainly, when we bring so diverse information together, we need to have building ontology. For example, this is because of the size of the slide, I show some partial ontology we developed for flooding. And in the flooding, when we look at the house as a unit of analysis, because most of digital twin are very much will be at the building level, right? We do the building level. We consider the using the building to link the different features of building, and it's a relationship. If I build a relationship for houses, it will allow me to link to nearby green infrastructure or the road system and to the other facilities. So utilizing the scene graph ideas, we can link the street view images to the other like civil facilities, and as well as many documents separated across government agencies and non-profit organizations and communities. And for that is when we look at the image here, for example, this is a typical image of a building, and there's on the right side, we list the 17 different design criteria which might impact the kind of the resilience of this building to flooding. So all these 17 designs could relate to many pages of the design menus. So when we link these together, it means anything now you are in building 3 dimension in building, we can immediately link to the design criteria. We change design criteria, the image here will also be designed. So I will think about is a more bring the digital twin with design, brings opportunity for the interactive kind of design. And we also building the annotation system to allow, because to me, the digital twin is not a top-down kind of the kind of design procedure. It's a both top-down and bottom-up. So bottom-up means we use a digital twin as a collective decision making platform, allow other designers, citizens, and volunteer to contribute their knowledge about how they understand why this design is not efficient or something like that. For that, we are building a huge search system. So anything in the digital twin or any kind of the 3-dimension thing, when you input, will immediately bring up some other similar images annotated by other experts, and certainly through the computer vision and other learning capability, we can quickly match different design capabilities. As I said, is we want to transfer the success or not successful stories from one community to the other communities. And not only that, is we are also looking to the, when you build a digital twin, when you bring the 3-dimension thing into the in the city, we need many critical information which are not automatically come with the model. For example, when you scan all the Google Street View images into your model to try to build the 3-dimension city, you still need to go through a calculation to find out what's for example, here is what's the elevation of the lowest level of floor. Why it's important? Because if it's flooding, the water, when the water go beyond your lowest floor elevation, that means it will enter your property. If it enter your property, they will disrupt your the property value. So for that is we building the algorithm in. So when you scan the 3 dimensions, when you have Google Street View, we can quickly come up with these kind of the indicators which allow you to do the modeling later for flooding response. So you might argue with why not we just send in a vehicle and do scan, and it's easy, you can build a 3D model. Because we are thinking about if you build it for the whole city, it would be very costly. You send it in vehicle to do all these kind of scanning, let alone if you are talking about the vast region, for example, Texas Triangle, the whole coastline of Texas. So we also, so digital twin to promote the social equity, we also need to have such ways to construct inexpensive digital twin for the large communities. So certainly there's many kind of the algorithm we can build in to reproject the Google Street View into the for different calculation. Yes, so we did use depth maps to extract the camera height from the depth map, allowing us to detect the lowest floor elevation. So yeah, so to when the Google Street View vehicle drive by, it will scan, will take a photo on the house at different angles, and we also utilize these information to help us to identify where are the floors, where are the doors, and we use some examples to download kind of this algorithm to a test in a coastal region in United States, and we did some certainly some cracked doors detection, some wrong doors, but we would do randomly sampling, and we will check if there's a wrong doors. We can verify, improve to annotation again to increase kind of the accuracy, and eventually when we compare it to the kind of the ground truth, the R square is as high as close 0.9. It's a very good signal, is allowing us to further using this kind of inexpensive way to quickly identify the information from the kind of the 3-dimension image. So why it's useful is like FEMA's model. It need certainly a building type, number of floors, but there's one very difficult thing for them to get is the first floor elevation. right? So in other words, digital twin certainly for when we capture the building information, it can very naturally go integrate with many kind of hazard model we really need, like a model parameters here. If you look at the model parameter, many of that is very much relevant building feature. So if we have more information about the building, certainly we can even enhance the famous hazards model provided by FEMA. So not only that, as I mentioned, the digital twins allow us to put a human being back to the center of the urban planning. So we are developing user cell phone apps. We're developing something called GeoVisuals, allowing us to navigate through landscape, and you still do lots of comments. I strongly suggest what digital twin need to have lots of comments, because currently digital twin is very much physical. That means, so that's I said is, what does this building mean to me? Some building inside is splendid, but if I have disability, I cannot access certain service. So any energy saving means nothing to me because I cannot access, I cannot operate. So I will be excluded from the the energy saving. So in our so when I built this kind of prototype, it facilitated people interaction, discussion through the adding comments. If you add comments, then I can use a kind of the text mining and using many knowledge graph way to link to find out why this space or place means so differently for different person or same person at the same time across different time. So we can also provide the privacy. And I think the digital twin, one thing we also need to keep in mind is data ethics, because when you have released so much detailed information about the buildings or human beings' interaction with the buildings, it will certainly release lots of sensitive information. So we have some kind of the early effort is, for example, I can chop it into different sites within different cells. In each cell, the information is wiped out, because in each cell, means everything inside is homogeneous. So for that is certainly you can also define your comfort zone is you don't want to release any heterogeneous information. So
there's only one minute left.
Yeah, yes, I agree. Yes. So so for that is we can also link different using the narrative. We can link many things in the digital twin, kind of link them as kind of together. Yeah. So the last thing, as I said, why we get people involved when we do the working, and usually they will tell you where I go, right? Turn left to right, but in the reality, this will only function for the people without disability. If people on the wheelchair cannot go through this kind of the working, so we also utilize when we have cities in the digital twin, we can also do calculation quickly to find out why what's the quality of the site work and where is the missed site work. So towards the end of my discussion is for when we move from digital twin to urban digital twin, we need to pay attention like in the planning context. We are mainly talk about the entire city. It's not only for the simulation environment, it's very much we want to test different policy options and put a human at the center. Yeah, so thank you for your listening to my talk. This is one of the blog I wrote for Rice University, talk about why the digital ideas and AI are so important for us to respond, to build the resilient communities. Thank you.
It's great.